before the lecture. Ask AI this question. Explain attention in Transformers to a fifth grader using a classroom example. When the teacher says, please pass it to her, you need to figure out what it and her mean by looking at the whole situation. Who's nearby? What objects are around? Who was just talking? 1. How is this like what your brain does when reading a sentence? 2. Old AI reads sentences one word at a time, like reading through a tiny keyhole. New AI, Transformers, sees all words at once. Why is seeing everything at once better? 3. Draw a simple picture showing arrows from it pointing to different words, with thick arrows for strong connections and thin arrows for weak ones. Paste this into ChatGPT, Claude, or Gemini. Understanding attention will help you see why Transformers are so powerful. In 2017, everything changed. Researchers at Google published a paper with a bold title, Attention is All You Need. It introduced the Transformer architecture and it changed AI forever. Before Transformers arrived in 2016 and earlier, models like RNNs and LSTMs processed words one at a time. It was like reading through a tiny keyhole, moving left to right. By the time you reached the end, you might have forgotten the beginning. Also, they were slow to train because you couldn't parallelize the process. But after Transformers arrived in 2017, models could process all words at once. It's like seeing the entire page at a glance. Every word can connect to every other word instantly. This makes them fast to train and allows them to power ChatGPT, Claude, Gemini, and all modern AI. The GPT in ChatGPT stands for Generative Pre-trained Transformer. You're learning the architecture that runs the AI revolution. Consider this sentence. The cat sat on the mat because it was tired. Question. What does it refer to? Answer. The cat, not the mat. How did you know? You looked back at the whole sentence and figured out that tired makes sense for a cat, not a mat. Mats don't get tired. Old AI reading word by word had a problem. It would read the, then cat, then sat, and so on. By step 8, the memory of cat from step 2 has faded. The AI struggles to connect it back to cat. It's like trying to remember the first word of a book by the time you reach the last chapter. Transformers solve this with attention. Instead of reading word by word, every word looks at every other word and asks, how important are you to understanding me? Let's see attention in action with our sentence. When processing the word it, the model effectively asks, how much should I pay attention to the other words? It might give the a very low score of 0.02, but it gives cat the highest score of 0.71. It ignores mat and sat. The model learned that it most likely refers to cat. Attention scores are like a spotlight. High scores mean a bright spotlight saying this word is important for understanding me. Low scores are dim, saying ignore this word. We can visualize attention as a heat map. Darker colors equal stronger attention. If we look at a simplified heat map, the row for it would have a strong dark block on the column for cat. The model learned this relationship automatically just from reading billions of sentences. Let's look at how attention works mathematically. For each word, attention computes 3 specific vectors. First is the query or Q, which asks, what am I looking for? Second is the key or K, which represents what do I contain? And third is the value or V, representing what information do I provide? Let's trace this with an example processing the word it. In step 1, it creates a query effectively asking, I'm a pronoun. What noun do I refer to? In step 2, every other word presents a key. Cat says, I'm a noun, an animal, the subject. Mat says, I'm a noun, an object. Sat says, I'm a verb. In step 3, we compare the query to all keys. The match for cat is high at 0.71, while the match for mat is medium and sat is low. Finally, in step 4, we use these scores to blend the values, so it now carries information mostly from cat. Think of it like a search engine. Query is your search. Keys are web page titles, and values are the content. Transformers don't just use one attention mechanism, they use multi-head attention to look for different patterns simultaneously. Head 1 might focus on grammar relationships, linking the subject fox to the verb jumped. Head 2 might look at positional relationships, linking nearby words like over and the. Head 3 might focus on semantic relationships, realizing that fox and dog are both animals. Head 4 tracks long-range dependencies. Each head learns to find different patterns. Combined, they understand grammar, meaning, context, and more, all at once. Let's look at the overall transformer architecture. It starts with the input, like the cat sat. This goes into the word embeddings we discussed in the previous video, plus positional encoding to add location info. Then it goes through multi-head self-attention, where words look at each other. Next is a feed-forward neural network to process the information. This repeats anywhere from 12 to 96 times. Finally, we get an output representing understanding or prediction. To give you an idea of scale, BERT-based has 12 layers and 110 million parameters. GPT-2 grew to 48 layers and 1.5 billion parameters. GPT-4 is estimated to have around 1.8 trillion parameters. Why did transformers win over the old methods? If we compare them, old RNNs processed sequentially, one by one, while transformers process in parallel, all at once. RNNs forgot the start of long sentences, while transformers remember everything. Old models were slow to train, whereas transformers are 10 to 100 times faster. Finally, while old models had a context window of about 100 words, modern transformers can handle anywhere from 4,000 to over 128,000 words. Let's look at the famous transformer family. First, there is BERT from Google, a bidirectional encoder. It looks at words from both directions and is great for understanding tasks like classification and answering questions. Next is GPT from OpenAI, the generative pre-trained transformer. It generates text left to right and is great for writing stories and chatbots. Then there is T5, or text-to-text transfer transformer, which converts every task into a text input and output. Finally, there is Claude from Anthropic, which is a transformer built with safety training. Transformers are especially important for languages like Kazakhstan. First, because Kazakh is agglutinative, words combine into long forms. For example, a single word can mean in our schools. Attention handles this well because each part of the word attends to related parts. Second, multilingual models like MBERT are trained on over 100 languages, including Kazakh and Russian. Third, we can use fine-tuning to take a pre-trained model and adapt it specifically for Kazakh tasks. Let's summarize the key takeaways. Attention lets every word look at every other word instantly. Old AI read word by word and forgot. Transformers see everything at once. Attention scores show which words are important for understanding each word. Multi-head attention finds different patterns like grammar, meaning, and position. BERT understands text. GPT generates text. Both are transformers. ChatGPT, Claude, and Gemini are all powered by this architecture. The 2017 paper, Attention is All You Need, started the modern AI revolution. Now let's answer these questions to confirm you understood the lecture. Pause the video if you need to think. 1. In the sentence, the cat sat on the mat because it was tired, which word should it pay the most attention to? 2. What do the letters GPT in ChatGPT stand for? 3. What year was the transformer architecture introduced? 4. Name one advantage transformers have over old RNN models. 5. In attention, what are the three vectors called? Remember Q, K, and V. Write your answers down. You'll need them for the next demo. In the next demo on visualizing attention with Hugging Face, you'll actually see attention patterns. You'll visualize which words attend to which. Attention heat maps in action.